Welcome students. In this video we will discuss about conductors and insulators. Water conductors, as you know that these are the substances through which heat and charge can flow easily. For example, human body, metals, earth, etc. Especially in metals, there are large number of free electrons. You must ask, what are free electrons? Actually, due to the temperature of the substance, each and every substance has some thermal energy. And because of that thermal energy, in conductors, the atoms, after absorbing some thermal energy, their valence electrons come out of the atoms. Here, and as these electrons are coming out, atom acquires positive charge, while these electrons has become free. In the same manner, in other atoms also, it is happening. And now these electrons which are obtained due to the temperature, these electrons can move freely inside the substance and can carry charge from one place to another place. Here one question arises, why these electrons are not able to come out of the metals? Actually, you have read about the work function or the threshold energy of any metal, which is the minimum amount of energy required for the emission of one electron from metal surface. At the normal temperature, these electrons are having the thermal energy, but their thermal energy is less than the work function of the metal. And hence, these electrons are not able to come out of the metal surface. One more thing, in the conductors, whenever the charge is given, then the charge resides over the surface of the conductor. Suppose if it is any conductor and you have to make it positively charged. For it, you have to detach some electrons from it, and you have detached the electron from this place. If the electrons are detached, so at this place some deficiency of the electrons will develop, and deficiency of the electron is considered as positive charge. Now immediately in the conductor, rest of the electrons adjust themselves to fulfill this deficiency, and as the electrons have fulfilled this deficiency, so deficiency develops at the surface. Mean to say, whole of that positive charge immediately is shifted over the surface of the conductor. One more thing, whether this distribution of the charge will be uniform or non-uniform, it will depend upon the shape of the conductor. If the conductor is symmetrical in shape, like a sphere, then this distribution of charge will be uniform. The charge density at every place will be same. And if the conductor is of irregular shape and you have given some charge to it, the charge will reside over the surface. But in this conductor, the distribution of the charge will not be uniform. If there is any sharp edge, then at the sharp edge, the charge density will be more. I will discuss it in detail later on, but you must know this thing. Now, coming to insulators. Insulators are those substances in which there are negligible number of free electrons or positive and negative ions are tightly bound. Such substances are also known as dielectrics. And here I have to tell you that in the insulating materials, if the charge is given to these insulating materials, then the charge remains at the localized region. Means if you have given some negative charge at this place, then this negative charge will not shift it to the surface of the conductor. It will remain at the same place. Clear? So I have discussed about conductors and insulators. Now next topic is electrostatic induction. What it is? Suppose if it is there is an electrically neutral body and near it any charged body is brought. Let us say it is positively charged. And now due to the electrical influence of these positive charges, it is seen that at the near end some unlike charge appears. And at the far end some positive charge appears. So, and these charges remain static till the charged body is kept near it. This phenomena is known as electrostatic induction. And here I have to tell you that this phenomena not only takes place in conductors, it also takes place in insulators as well. Suppose if it is any conducting body and near it you have brought any charged body, and when you have brought suppose positively charged body, then as I have discussed that the conductor have large number of free electrons. So because of this positively charged body, the free electrons present in it, out of those electrons, some of the electrons shift towards the positive charge because of the attraction, and as at this end the electrons, whatever the some electrons have shifted to this side, so at this end then there will be excess of electron, so negative charge appears, while at this end there will be the deficiency of the electron, the electron's density will be decreased, so at this end some positive charge occurs. Means very easily in the conductors, because of the shifting of the electrons, the phenomena of electrostatic induction occurs. On the other hand, in the insulators, suppose if it is an insulator and near it you have brought a positively charged body. Suppose it is a positively charged body, and now as it is insulator, in which I have told you that positive and negative ions are tightly bound, or the electrons are tightly bound with the nucleus. Because of the presence of this positive charge within the molecules, what happens? The negative ions are slightly shifted towards the positive charge, while the positive ion is shifted away from the positive charge because of the repulsion. Means within a molecule there is some separation of the charges. It happens in every molecule like this, and if it is happening so in each and every molecule, you can observe that at the near end here, at the near end the negative charge is appearing, while at the far end some positive charge is appearing. In this manner, we can say in insulators also this phenomena of electrostatic induction occurs. But here you are observing that in conductors this phenomena is taking place easily. While in insulators, there is with a little bit difficulty. Got it? So, here I have to tell you that this phenomena is also known as electric polarization. We can define electric polarization. What it is? That the separation of the charges in electrically neutral bodies. It was electrically neutral. Now within the substance, the charges are separated. Here also, in the insulators, charges are separated because of presence of nearby charge. So, it is the electric polarization or electrostatic induction. Here one thing I have to tell you, as I have discussed, that the difficulty level of this phenomena is different for different materials. So, how easily this phenomena of electric polarization or electrostatic induction can take place is represented by a term named as dielectric constant, which we denote it by letter K, or it is also called as relative permittivity. It tells how easily any substance, any medium is electrically influenced by the charges. For any substance, more is the value of K, more easily the medium, the substance is electrically influenced. That is why for more conducting materials, the value of K is more. For insulators, the value of K is less. For example, the value of K for air, this is the generally we say the most insulating medium, and for it the value of K is 1, the least. For glass, the value of K is near about 6. Means glass is more easily it is electrically influenced. For water, the value of K is near about 81. For conductors, as I have told you that in these the induction takes place very easily. So for conductors, the value of K is considered as infinite. Got it? In the last, here I have to discuss that what would be the values of the charges which have appeared in these substances. For it, you must know that the charge which you have brought, it is called as the inducing charge. And the charge which have appeared in the electrically neutral bodies are called as induced charges. And the relation between this induced charge and the inducing charge is this one: Q dash equals to Q into 1 minus 1 by K. And therefore, in the conductors, for example, it is a conductor, and as I have told you, the value of K is infinite. So, if the inducing charge is Q for conductors, if we place the value of K for the conductors, you will get Q dash equals to Q into 1 minus 1 by infinite. It means the Q dash will be equal to Q. Means in the conductors, the induced charges will be same as the inducing charge. On the other hand, in the insulators, suppose if it is glass, its a value of K is 6 and the inducing charge is Q. So we have to obtain the value of induced charges. So induced charges Q dash will be equal to Q into 1 minus 1 by 6. It means it will be 5Q by 6. Got it? So in this manner, here I have told you about the electrostatic induction and the dielectric constant. That's all.